Okay, question 16, last occurrence. Given a target integer t and an integer array a sorted in ascending order, find the index of the last occurrence of t in a, or return -1 if there is no such index. So the function last occurred, there are two input types. One is int array and the second is integer for the target. And the output type is integer to indicate the index of the last occurrence of the target integer. And the assumption here is that the input array is sorted in ascending order, and they can be duplicate elements. And possible corner case is when array is null or when its length is 0, then we just return -1. And the solution here is binary search plus the post process. Now looking into the code. First part is sanity check. First, we check if the array is null or not. The second is to check if the length is 0. If any of these happens, we return -1. And next is to set up the pointers. First, left is 0 and right is array.length -1. These two pointers define the search range. And next is the while loop. The condition of the while loop is left less than right -1. The reason we not set up this way is because when there are only two elements left in the search range, we don't go into this while loop. Instead, we use the post process to check which element is the one we are looking for. We're not doing this because we try to avoid a dead loop. Okay, now looking into this loop process, first we calculate the mean index and then we compare the mean element to the target. If the element equal to the target, then we move the left pointer to the mean because we are looking for the last occurrence. So everything before the mean are not the ones we're not looking for. Okay, and next, if the array mean is less than the target, that means the target is in the right side of the array, then we move the left pointer to mean +1. Otherwise, we move the right pointer to mean -1. So at the end, when there are only two elements left, then we get out of this loop and we do the post process. And in the post process, we first check if the right element equal to target or not. If yes, we return right. Otherwise, we check if the left element equal to the target. If yes, we return left. If not, we return -1. Okay, so the time complexity of this function is log n because we reduce the search range by half in each iteration, and the space complexity is O1 because in each iteration we don't create a new variable or a new object.